All right, welcome everybody. We're going to give a few minutes for folks to get in here. Hope everybody can see my video and that it's big on your screen. I'm still seeing Rebecca, so I don't know if that means I'm not pinned or not. But see if I can pin myself. There we go. Now I can see it. All right, so welcome to this afternoon session on making VMware vDefend easy. My name is Chris McCain. I am part of the Application Networking and Security Division at VMware by Broadcom. Also a very loving and loyal member of VMUG, so you probably see me at a lot of events doing a lot of these online sessions. It's always a good time to be in front of the VMUG community. These global virtual events are growing and growing, so it's great to see the community continue to support these online events. All right, so let's talk about vDefend. When it comes to security, there's often this misconception that security is complex or that it has to be complex. Now, certainly when we talk about security in the context of enterprise design or the characteristics of enterprise design, we'll think about things like availability and manageability, performance, recoverability, security, right? Those are all key areas of enterprise design. But you have to realize that there are situations that you come across where you don't have the opportunity to get all of these things the way that you may want them. There's compromise that has to be done between these things. So there's situations like, say, security and manageability. Security and manageability, if you ever have to secure something, it's never going to be easier to manage than not having to secure it. But that doesn't mean that it has to be super difficult to manage. So we have to find that balance between what is actually manageable, but at the same time, how do we get security? Because what happens is if something is too hard to manage or it's too difficult to create the security mechanisms or controls, then we just don't do it. It leaves us in a position where we're still vulnerable. Security and performance is another one. Nothing more secure should ever perform better than not having to secure it. But that doesn't mean we actually it has to be impactful. It doesn't mean that we wouldn't do it because of how tremendous the performance is. So again, we have to balance between the two of them. How do we pick security technologies? How do we pick solutions that are going to be manageable, yet provide a buy down of risk? How do we pick solutions that are not going to impact performance in such a way that we wouldn't want to secure it, right? Minimal impact. And that's where vDefend really has an opportunity to shine, because from a manageability perspective, we've built an infrastructure, both the UI as well as access to the API, that makes it very easy to manage security at scale. And that's because we don't rely on traditional type of security design or firewall security design, where you're leveraging IP address or IP subnet as a source and a destination to control traffic flows, right? If you think about those types of designs, it means that every time I add a new IP subnet or I want to control access between two systems, I have to know the IP address, source, and destination, or I have to include the IP subnet. And now there's another one. Now I got to modify the rule. And now there's another one. Now I got to modify the rule. There's this constant management that's required when you look at those types of legacy models for firewall management. So with vDefend, the management interface as well as the API, we give you the ability to create constructs, these logical constructs that we can use inside of policy that make it easier to do. So let's talk a little bit about vDefend architecture to start. So we've got our hypervisor. So there's ESXi. Of course, underneath that is the physical network. And sitting on top of that is all of our workloads. And if you're not familiar with vDefend, this is just a quick elevator pitch here on what the architecture looks like. In a traditional network, you're going to have a physical firewall out here, and that physical firewall is going to protect everything that's going in and out of the data center. Well, what we've done with vDefend is we took this concept of the firewall and we abstracted it into the hypervisor to be able to enforce policy at the VNIC level of every virtual machine running on the hypervisor. So think about that. It's a firewall in the hypervisor sitting in front of every VNIC of every virtual machine. Now, when you think about that, and then you're like, oh man, I've got 500 machines, I got 1,000 machines, I got 10,000 machines, I got 40,000 machines. Are you talking about that many firewalls? 40,000 firewalls? Yeah, it's exactly what we're talking about. But that's why the manageability, that's why it was important for us to create a new way of applying security policy, of creating security policy, because trying to manage or micromanage firewall policies across tens of thousands of VMs and doing it by IP address, it's just not a feasible solution to do that. So this feature in the hypervisor is what is called the distributed firewall. Okay. Now, we also have the opportunity to help close out or build out the security story. Let's say we have a VLAN down here, and that VLAN has a physical server. And then we've got another VLAN down here, and that VLAN's got a physical server. Well, you can see clearly here in the flow of traffic that the in-hypervisor firewall really wouldn't do anything for those systems. So we have another feature called the gateway firewall. And the gateway firewall, and again, this is just conceptually, but the gateway firewall we can put here as a way of controlling traffic between the non-virtualized workloads. And that gateway firewall can be deployed as either a physical machine or it can be deployed as a virtual machine. So you think about the traffic flow between these two VLANs, going from one VLAN to the next. The default gateway would be the gateway firewall, and then the gateway firewall would determine whether or not the traffic was allowed. If it was allowed, then it puts it back onto the next VLAN. Up here in the hypervisor, obviously, we're handling VM to VM traffic. We can handle VM to the physical traffic. We can even handle physical to the VM traffic because we're doing the inspection of the policies upon both the ingress and the egress of these virtual machines. So it gives us the ability to say, well, look, if you want everything inside your data center to have one single management plane, then we can do that with vDefend. And so what you end up building here is a dual vendor strategy with respects to the controlling of traffic in and out of and within your data center. So your traditional Palo or Cisco or Checkpoint, whatever firewall you're using, would still be here to protect ingress and egress. And then within that private cloud environment, we would have the vDefend portfolio that's protecting everything inside of here. So we have a really strong security story to be able to protect those things. As part of the vDefend firewall, there's also a tool called Security Intelligence. Security Intelligence is a microsegmentation planning tool. If you think about the concept of microsegmentation, that is understanding and controlling the flows of particular applications. That's the hardest part of that is the understanding. So security intelligence, we can actually point it to a particular portion of the infrastructure and it will come back and it'll give you a list of all of the flows and some rule recommendations, and we can push a button and convert all of those into actionable policy. So it's a way to simplify the microsegmentation of particular applications or any given application within your environment. Now, that being said, the challenge with microsegmentation obviously doesn't come from the technology, because we can make it easy to find the flows. We can make it easy to build the policies. The challenge is more around the humanistic, you and me, the human part of this, because if I'm the virtualization engineer and I'm trying to, boost my value in the organization, so I'm trying to apply more security policy to protect the things that are running in my VMware environment, I don't own that application. So even though I've been given this powerful tool that allows me to understand the flows and convert to policy, I may not know all of those flows. I probably don't know all of those flows. So for me to take accountability and be the one who pushes that button, that's tough to do, because if something's wrong with the policy or something happens because of the policy, you become accountable to that. Now, just a little caveat here, in a brownfield environment, just to make you feel safe, in a brownfield environment, the default policy for VMware vDefend's distributed firewall is an allow policy. So even if this security intelligence was monitoring, and let's say I monitored for 30 days, but every 60 days, there's a data dump from a database out to something else, and I didn't capture that in my policy, it's okay, because the default policy will catch it. So it's not going to break the application. To be honest, what I'm more concerned with, if I'm the vSphere engineer and I'm looking at these policies and I'm the one that's responsible for it, what I'd be more concerned with is if there's a particular flow that's a malicious flow currently. In other words, there's a threat actor already in the environment, and one of these flows that was captured is the threat actor performing lateral movement. And now unknowingly, I'm building a policy that's allowing that flow to occur. So again, when it comes to microsegmentation, it's like the nirvana of security, right? Being able to control intra-application traffic. But it's a difficult thing to do because we as humans have to approve and say, yes, that looks good. That's how we want things to happen. The policies that are built, right, are built according to the best practices. They're efficient. They use applied to. So all of the things that we would want to do as humans when we build policy, security intelligence is very smart in being able to do that. So I've had customers who ask about using things like ARIA operations for networks, and it has complete visibility across the entire architecture. Why would I use VRNI? Why would I use security intelligence? And the reality is those two, they're not mutually exclusive. There is some overlap, but I think they work very well together in the following scenario. Security intelligence, as I mentioned, you would use specifically for your microsegmentation planning because it makes it so much easier. And then VRNI would be the broader network monitoring tool that you use when you want to see from this VM through these firewall rules to this hypervisor, to this switch, to this router, through this firewall, to this router, to this switch, to this hypervisor, through these rules, and then to the... So when you want to see all of those steps along the way, there's nothing that beats VRNI in the level of detail that you get when you're looking for information about flows. But if you want the simplicity of building rules quickly and efficiently, then security intelligence. So I look at them as very complementary solutions and use them for what they do best, whether it's the planning and implementation or whether it's the visibility across the entire infrastructure. Okay, so when we look at the rest of the portfolio, so this is our vDefend firewall set of products, and then we've got our vDefend ATP, and ATP, our advanced threat prevention. We add into the hypervisor IDS IPS capability, so the ability to look for known bad flows, known bad traffic, trying to get into a system. So another great opportunity like the DFW to be proactive in your security, right? As opposed to reactive. Let's proactively block the things that we know are bad. Then ATP also includes network traffic analysis, or NTA, and this is the ability to capture the information about what's going on in our environment and then apply machine learning to establish a baseline. And when we deviate from that baseline, when there are anomalies, we can notify about these anomalies. So two particular systems that, according to the baseline, have never communicated, and now all of a sudden there's communication, I may want to know about it. If there's a particular virtual machine communicating out to the internet or some external source that we've never communicated, I might want to know about those types of things. So now we're starting to leverage all the rich analytics that we can get through vDefend because we're built into the hypervisor. So no spans, no taps, no sampling, but collecting all this information and then applying logic to it and learning from it so that we can give you really rich data about all of this. So then we got NDR, network detection and response. And now we're going to take all that data that we're collecting, that rich data we're collecting that we were analyzing for anomalies, but we're not just going to analyze for anomalies. We're also going to analyze to see if we can find patterns of traffic that match known attack campaigns, and we'll map it to the MITRE ATT&CK framework. So if you're in security operations, if you're familiar with the MITRE ATT&CK framework, it's the de facto standard for understanding the different stages of attacks. And so what we'll do is we'll collect that information and we'll provide not only a timeline of everything that happened. So there was a breach, there was command and control, there was lateral movement, there was command and control, there was lateral movement, there was exfiltration, there was a ransom event. All of these different stages of the attack will give you a timeline, but we can also provide a map, a visual map that shows you everything that has been impacted by it. And if you don't like the idea of a timeline, if you don't like the idea of a map, but you like the idea of a chatbot, we actually have a chatbot, and you can talk to the chatbot and say, hey, show me all systems impacted by this particular campaign. And there you go, shows you the systems. And you could say, what are mitigation options that I have for this? And then option one, you could do this. Option two, you could do this. Would you like to do one of them? Yeah, I want to do option one. And it'll go actually mitigate and help repair. So we're not only leveraging AI and ML to help you see what's going on in the environment, and be able to react to it, but we're using learning models so that you can interact in natural language and be able to help mitigate against these types of things. So when customers always ask me, like, well, who's supposed to manage this thing? Because we have a security team, we have our virtualization team, we have a network security team. Who's it supposed to be? There's no right answer to it, but what we're building is a product that's easy enough to manage and operate, that if you were, say, building a private cloud team and you had people within the private cloud team that were responsible for security, and you want dedicated tools for the private cloud that are purpose-built for the private cloud, then those individuals would have what they need. If it's a virtualization engineer and all they're going to do is build some firewall policy, we can take all the rich data that we get and we can send it out to a third-party SIEM or source, or the SecOps team can see the data and manipulate the data alongside everything else that they collect. So I don't want you thinking that what I'm showcasing here from a security product portfolio is an all or nothing proposition. You can pick and choose the pieces that you would like to use out of this based upon your comfort level in the technology, how deep you want to go into the levels of protection, where you're comfortable with buying down risk. So that's all up to you. And there's no timeline either, right? These things are not predicated on one another. So as a customer, you might say, well, I want to start with some simple DFW rules, and you could start there. Once you do that, you could say, well, now I want to do some IDS, IPS, and then boom, I'm done. There's nothing else I want to do from a virtualization perspective because my SecOps team is doing all of their special things, so I don't need to do those. Or I've had customers that say, hey, we think there might have been a breach now. We might be compromised now. We really don't have any of the information. You could jump straight to NDR. You could deploy that and start gaining visibility into the infrastructure. So no one place that you have to begin. It's a matter of what are you trying to solve? What's your comfort level? How quickly are you trying to solve it? And then you can pick from there. But ultimately, for most customers that today are looking for the step one, I would say step one is control lateral movement. Because in anything that attackers want to do, step one is get in. Once they're in, now they want to move. And they don't just move in every direction that they can go. They move very strategically. They move very surgically, very precisely, so that if you are tracking, there's not a whole lot of things to see because they're moving from one thing to the next, usually no more than 3 to 4 hops. So they're very smart in the way that they move. Now, that being said, when we talk about, when I started this whole conversation with security and manageability, we need to figure out how to do this in a way that doesn't radically overhaul the operational model of the organization. Or I should say this, doesn't require us to radically overhaul the operational model of the organization. Because if I came in and said, hey, we've got this amazing security stack and you can do all of these things, and sorry, dropped my phone. If we can do all of these things, I got a little excited there and knocked it right off. We can do all these things, and all you got to do is hire a bunch of new people, and it's going to take you hundreds, if not thousands of hours to get protected. You wouldn't do anything, right? It would be too daunting of a task to do anything. So we got to be able to do things quickly and easily. And that's what I want to show you now through a series of some Lightboard stuff and some demos, is how do you buy down risk quickly? How do you buy down risk in a way that says, I don't have to spend hundreds or thousands of hours, but I am actually making a dent in the security posture of my organization. I am doing something that's going to eliminate a malicious threat actor's ability to execute or perform in the event that they do get into my infrastructure. And so to do this, I think the best way to think about your strategy is to think like a malicious threat actor, right? What would a threat actor want to do in the event that they get into the environment? What are the techniques? What are the common protocols, the steps that they take in order to achieve an end result of being able to exfiltrate and ransom a particular set of information? So if you look at the anatomy of attack from that perspective, whether it's phishing, social engineering, somebody clicks a link, whatever it might be, ultimately, once they get into a system in the environment, they then want to move from system to system until they find something of value. Now, that movement can happen in different ways. The top 3 ways that lateral movement happens is using RDP, the ransomware distribution protocol, or SSH, or SMB, particularly version 1, which is really old and really vulnerable protocol. So if RDP, SSH, and SMB are what an attacker is trying to use to move, then maybe if we just start there, then we will have the ability to make an impact in the security posture, but it won't take us hundreds or thousands of hours. We won't need new staff, because these particular protocols are actually very predictable protocols. We know how they are supposed to operate. So I'm not suggesting we block them, but I am suggesting strongly that we control them in the environment. There's a big difference there, right? I don't want RDP to be allowed from any system to any other system. So I want RDP, but I just want to control the way we utilize RDP in the environment. So maybe I have a particular system that is a jump host. So there's my jump host. And I'll allow the jump host to get to these other systems via RDP. But if you're not on a jump host, I'm not going to allow that. Now, let's be clear. When I talk about RDP, a malicious threat actor is not opening a terminal services client and trying to log in to get to the GUI. You know, we're talking about just leveraging the RDP protocol and open port to be able to do RDP hijacking, at which point they could submit malicious code through that open port and protocol, etc. Right? So we're trying to ensure that if an attacker gets into the environment, that they can't use RDP or SSH or SMBV1 to be able to move. And just think about this. Even if I can stop that, if I can just stop them from moving in the top 3 ways that they move, I'm hoping that that's enough to deter them into just going somewhere else. Because for most attackers, time is money. And the longer it takes them to find something of value, the longer it takes to actually receive a payday, to get something out of the attack. So if an attacker gets in and they look at their hacking 101 handbook and it says, oh, do an RDP injection to move laterally, blah, 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 whatever it is. And they can't do it. Step 2 says use SSH. Oh, they can't do it. Step 3 says use SMB. Oh, they can't do it. Well, if you're an attacker, unless you're just really hell-bent on attacking that particular organization, or you're a nation state, or whatever it is, you're probably just going to go find a different target, find something that you think there's going to be a faster way to come into some money, as opposed to continuing to try and hit an infrastructure where clearly there are some controls in place to prevent those common methods of being able to move throughout the environment. The other one that I'll mention also is when attackers want to exfiltrate data, and then we'll jump into some demo here. When they want to exfiltrate data, DNS is probably the most common way of exfiltrating data, which is, it's weird, right? You're thinking DNS, oh, it's name resolution, but man, it's awfully clever when you think about it. So, they're not going to want to use FTP or one of these protocols that's known for file transfers, because you might have a physical firewall that's blocking it. You don't want some type of alert. So you want to find something that will be allowed out the firewall, but won't be super suspicious. So DNS, well, it's name resolution. So if the internal resources are accessing external entities, then you would need to allow name resolution to leave in order to be able to get back the resolution of the name to IP mapping of wherever they're trying to go. So it's a pretty clever way of hiding the data exfiltration inside of a common port and protocol within the environment. Okay, so the last thing I want to talk about before we move into some demo is, once you've laid out sort of these infrastructure rules, right? I'm protecting these common things. And then you think, okay, well, what can I do next? What's something else that's easy to do? I think that aside from maybe jumping to IDS, IPS for particular apps, I think looking at zoning or breaking up your infrastructure into different areas is a very powerful and easy thing to do, because you want to limit the blast radius. You want to limit the attacker's ability to move throughout the environment. So even if I'm protecting these things, if there's a different port, a different protocol that they want to use to move, I still want to ensure that within the different zones, the different categories of applications and services that I have, that they can't do that. So just put a little simple example here. Let's say that there's prod, there's test dev, and there's DMZ. And these can be 3 different clusters. You could have, 5 clusters in prod, 2 in test dev, 1 in the DMZ. It doesn't really matter. These could also be all in one cluster or spread across 6 clusters where there's workloads from each one of these in all 6 clusters. It's fine. We're talking conceptually here about these 3 different zones. Does it change the way that I would go about performing what I'm about to talk about or accomplishing it? It does. Okay. It might actually be easier if these were all in distinct clusters because I could write a script that says, hey, everything in these clusters, tag it as prod, and everything in these clusters, tag it as test dev. Everything in these clusters, tag it as DMZ. If it's all spread across different clusters, the different clusters having, a multitude of these different zone categories, then I have to find a way to kind of figure out which ones are which. But ultimately, once I build the tags, I can take the tags and build a security group for prod. So if you are tagged as prod, then you are part of prod. If you are tagged as TD, then you are part of TD. If you were tagged as DMZ, then you're part of DMZ. And the beauty of this is that this has nothing to do with the physical network. So these could be different subnets. They could share the same IPs. It's irrelevant. That's one of the powerful factors with DFW is there's no tie-in to the structure or the way that the physical network has been designed. If you think prior to this type of thing, if you wanted security, you would typically build the VLAN boundary and use a firewall to control traffic between VLANs and say, oh, there's my security boundary, unless you were getting into the mix with PVLANs and stuff like that. So if that's not the case, then really it was the VLAN became that security boundary. That goes away with vDefend because same IP subnet, different IP subnet, we're going to inspect upon ingress and egress regardless. So it's kind of nice when you think about having this because it means if you ever get into a position where you have an opportunity to kind of redesign the data center and think about that next generation level design, it's nice to not have to rely on the IP subnet as the security boundary because it gives me an opportunity to create larger IP subnets without having to change the security model that I'm trying to achieve. So nice little option there. Look, then within prod, I've got some apps that I'm going to designate as part of an open category. So apps that I don't want to spend too much time securing them because their risk profile is rather low. And then I've got some apps that I'm going to call secure. And then what happens is once I've built out the tagging and the grouping, so tag of prod, tag of TD, tag of DMZ, tag of open, tag of secure, and then I build my security groups, prod, TD, DMZ, open, secure, then I can start to build policy. And I mean, look, if you think about it just clearly, you might say, look, I don't want DMZ communicating to prod. So if the source is DMZ and the destination is prod, we're going to block that traffic. Test dev, going to prod, I'm going to block that traffic. Open, going to secure, I'm going to block that traffic. So we start building these policies. Now, these, I'm going to show you here in a minute what this looks like. And it's cool to have these done. But ultimately, once let's say you have 6,000 virtual machines. And so you go out and you build this and you tag everything and everything's working great, right? And I've limited the blast radiuses. I'm down to a blast radius of open versus secure within the prod environment, everything in TD, everything in DMZ. But what about moving forward? What about the next virtual machine I built after those 6,000 are done? I don't want to have to fire off a ticket to an individual and say, hey, I'm building this new VM. And by the way, the VM is in prod and it's part of open. Can you go make sure it has the appropriate tags? So I need to figure out how do I leverage the tagging taxonomy to integrate into a self-service portal where now my users can actually go in and choose, hey, I'm deploying this new app or I'm deploying this new VM, and I'm going to pick that it is part of TD. And so now it automatically gets the tag as part of the automation and orchestration from the self-service portal. And as soon as that VM is powered on, it's already having to follow the policies that have already been predefined. And, this is kind of ultimately how we want customers to start to see what they can build in a private cloud and then start to consume in a way that provides all of this additional value to them. Okay, let's look at some demos here. So let me fire up this first one, and we're just going to walk through this demo that is going to show us exactly what it's like to secure RDP. So we have in our inventory, we're going to create a tag. And that tag is going to be for our jump hosts. And we're going to pick our jump hosts. So we can do a little search here. And of course, this demo is purpose built, right? If you don't have a good naming strategy, you'll just search through the interface and find them. So I'm tagging my jump hosts. I can give a scope. Scope is important. You'll see here shortly when we get into the environmental stuff. And now I'm going to go to distributed firewall. And I'm going to start building some policies. So we're going to have a policy here for RDP. And this RDP policy, we're going to build some rules. So our first rule here, we're going to allow to the jump host. So if the source is any and the destination is the jump hosts, so we're going to create a group for the jump hosts. And you'll see here how easy it is to create a group. I'm just going to click set, and then we're going to add criteria. So this group is going to be made up of any virtual machine that contains a tag that equals jump hosts. And that's how easy it is to build a group. You could do static membership if you want. It's fine. You could do virtual machine name. You could do operating system name. So there's a lot of different options there. You'll find that building groups and policies is as much an art as it is a science because of how flexible you can be. So we've got the any to the jump, and now I'm going to search for RDP. We've got our predefined services here, and there's our RDP. So port 3389. Now I'm going to add in, so there's our first rule. I'm going to make sure that the rules are ordered properly because the rules are processed from top down. It's actually left to right, top down. If you see at the top here in a moment, you'll see Ethernet, layer 2 infrastructure, environment, applications. So those are all categories or just ways of organizing rules, but rules are processed left to right, top down. So we've got an any to jump, we've got a jump to any. And these two rules we're going to set to allow. There's a little fancy move here, dragging the RDP down so I don't have to go search for it again. And now we're going to get our final rule. I got to make sure this one's at the bottom because this is going to be the rule that says if it's any, and there's my fancy drag, I missed it. There's my fancy drag and drop of RDP. And now we're going to set this to drop. And again, the reason that we're doing this, if you remember, I mentioned that the default policy is set to allow. So if the default policy had been changed to a block, I wouldn't need that third rule. I would be fine without that third rule. But if you're in a greenfield environment and you can set that thing to block by default, that's a luxury that you have, and you wouldn't need that additional third rule. So that's RDP. I mean, that was it. That was a 4-minute video. That's what it takes to be able to block control the number one protocol used by attackers to move laterally. So that's a pretty powerful, easy, very easy thing to do. And honestly, that it doesn't matter whether you had 50 VMs, 100 VMs, 10,000 VMs. The concept is still the exact same for all of those. So it scales really well in the environment. Okay, let's look at another one here. I mentioned DNS. So I'll show you now how to protect DNS in the environment. This one's going to be a little bit different because we're going to use a static group membership. Jump ahead here. So we're creating a tag. This tag is for internal DNS. And we're going to apply a scope. We're going to choose our DNS servers. So there's our dev DNS and our prod DNS, couple prod DNS. And that'll be our internal DNS tag. We're not going to do an external DNS tag because those are entities that I don't control. So it doesn't make any sense to have that tag on those. So we're going to have our groups now. We'll do our membership. So internal DNS. Oh, there they are, right? We put the tag on, it automatically populated. Now we'll go to our external DNS. We'll look at some IP addresses and type them in, and we are good. So what do we need now? We need our rules to control how DNS operates within our environment. And I'm going to fast forward here to the final rules, and I'll just walk you through them. You don't need to watch it be built. So let me see. We're almost done there. Okay. Let's see what we got. All right. So we've got an any. Oh, let it set. Here's the first rule. Any to the internal DNS. So any to internal, we're going to allow. If it's DNS traffic, we're going to allow. If it's internal to external and it's DNS, we're going to allow it. But if it's, scroll back here just a little bit. There it is. If it's any to any and it's DNS, we're going to block it or drop it. So again, I wouldn't need that third rule if my default policy wasn't the way it is, but that's it. 3 rules. So 3 rules to block the number 1 protocol used to move laterally, 3 rules to block the number 1 protocol used to exfiltrate traffic. Okay, now, last thing I want to show you here, because I think this one's a pretty cool one, is dealing with this environment stuff. So I'm not going to show you how these rules get built, because I think it's pretty self-explanatory based on what you just saw. But watch this. This is pretty interesting. When you're ready to tie in automation, when you're ready to leverage your tagging taxonomy so that a human doesn't have to be involved, and you want infrastructure to be secure by default. This is ARIA. And what happened here in ARIA, this beginning of the video is just kind of showing that all these different tags exist between prod, TD, DMZ, open, and secure, and that there's some policies, right? So it's building all the policies. But check this out. So here in ARIA, there's an object. It's called security tags, but that's just for the demo. Imagine this as a self-service portal that your users come to, and they click an object in order to deploy 1 or more new virtual machines. And when they click to deploy those virtual machines, it takes them into an interface where they can provide the specific information about this deployment. So what is the project? What's the deployment name? How many VMs do you need? Right? Your username, password, etc. But look at this, environment zone. So what this is doing is it's going to vDefend and extracting all of the tags with a similar scope, the scope of environment. And then the user now chooses production, test dev, or DMZ, because that's going to put the workload into the right logical group to get the tag to control the way that it communicates. So in this event, right, let's say they choose production. So come on, choose production. Now look, another one popped up. I'll pause it real quick. Another one popped up that says, well, what application security zone are you in? And so what we're talking about now is, are you open or secure? So if production, now you have to choose open apps or secure apps. So we're allowing the user to designate where this workload belongs, but by doing so, it's automatically picking up the right tags to determine how this thing is supposed to communicate. So now we're really getting to the ability to build completely automated infrastructure where we don't have to continue to ask people to do things or to tag things or get things ready before they go out into a production environment. So I think it's really cool when you start to ask yourself, where is the value? Where is the value in a private cloud? What am I saving? What am I getting? What am I going to be able to do? Well, you're going to radically improve your ability to secure everything running in the private cloud. And you're going to radically change the operational model in a way that says, I don't have to continue to do everything manually. I can leverage the infrastructure I'm building and tie that into orchestration, which, by the way, Andrew H., who's on the session here answering questions, he's the automation guru. He actually built that whole thing together with some guys from the ARIA automation team. But it's it's really powerful when you can start to bring these different pieces of the VCF platform and tie them all together in a way that supports making it easier for how you operate your business. And I just showed security, but if you want to throw networking in there, if you want to throw a checkbox for IDS IPS, or you want to say, oh, it's a SQL server, so it only gets certain policy, you just be creative. Think about all the things that you can do, the way that you can build the orchestration so that all of these workloads are secure by default. And it's really a very powerful tool. So I think with that, I am out of time. I didn't see too many questions come in unless Andrew was just cranking away at some of those questions. But we do appreciate you attending today and look forward to seeing you in future events. Thanks again.